Hi guys, happy Monday. All right, so as we talked about, right, today is a full distance day, so there won't be any live Zooms. Some days it'll be a quiz that I give you guys on a Monday. Today happens to be a notes day, so what I'm going to do is do this screencast, and then I'll put it in a little assignment, and watching it gets you the points for the assignment. Okay, and then there'll be the homework that's attached to it. Okay, so basically what we're doing, you guys, and for those of you who've been participating in class kind of understand that we've been working with a simple scatter plot, right? We have some variable here, x variable, and we have some y variable, and we go out into the real world and we collect data, and our data looks like a plot of points. And at this point you guys should be able to describe what you see, right? This is clearly a positive relationship between x and y. As x increases, y tends to increase, and do all the other things we talked about with correlation and the stuff that was on the quiz. And so where we're moving today is, now we've kind of talked about this, but we're going to officially do it, is we're going to come up with what's called a regression line. A regression line. Okay, we were actually going to refer to the one, there's a particular line, it's called a least squares, and I'm not going to get into detail about why it's called that, but a least squares regression line in your brain is just that magical line that fits the data. Okay, and we label this line, and this is all in your notes that I'm going to go back to, so don't worry about it. This is going to be a y hat equals a plus bx. And from algebra 1, right, this is you guys are used to y equals mx plus b, but this is a little bit different form. But the number that's in front of x is your slope, and the other number that is lacking the variable is your y-intercept. You guys have all taken enough math, I think, to understand that. The slope is always the number that goes with the x value. Okay, and so what we're going to do is we're going to come up with this line because, right, we only have, it looks like I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11 data points. Now what we can do is we can use that line to predict some x value that we don't have data on, right? So if I want to know about an x variable that I didn't collect data, right, it's not one of these red dots, I can just plug it into the equation of the line and come up with a prediction. And this happens all the time in the real world. You go out and you collect data, and then you use that to predict, right, an outcome for a given input. Okay, and so on your notes, it talks about what a regression line is here, so nothing big. And it gives you the formal equation, which we just talked about. This little guy is called a hat. Okay, so this is the predicted value, right? It's not the actual value because it's not coming from data that we collected. It's not a dot. It's a point on an imaginary line that goes through the data. And then, like I discussed as well, b is the slope and a is the y-intercept. Okay. And so, we'll read through this example, and then we'll talk about the picture down here. But it talks about, this one's called tapping on cans. It's in the textbook too. But it says, don't you hate it when you open a can of soda and some of the contents spray out? Two AP statistics students, Carrie and Danielle, wanted to investigate if tapping on a can would reduce the amount of soda expelled after the can has been shaken. For their experiment, they vigorously shook 40 cans of soda. Kind of sounds like fun, something my daughter would do. And then randomly assigned each can to be tapped on for 0 seconds, 4, 8, or 12. And then after opening the can, cleaning up the mess, they measured the amount of soda that was left, right? Because if it fuzzes up or fizzles up and explodes, right, some of the liquid leaves, so they measure what's left. And you can see the data below. And so I think, you guys can understand here, 0 seconds, that means they did not tap at all. This is how much was left. And then they tapped for 4 seconds. All these dots represent those 1, 2, 3, 4, 5 cans, right? And how much liquid was left. So it seems like after tapping for 4 seconds, there's more liquid left, and 8 and 12. So it definitely seems like there's this relationship, right? That the longer you tap, the more, right, soda is left in the can, which means it didn't explode as much. Okay, so here's our regression line, right? So this line right here is y hat equals, from above, 248.6 plus 2.63x. Now, you'll notice that I wrote y and x and they used words. I'm okay with either, right? So you can see here that tapping time is your x variable and soda is your y variable. So that's why they wrote it. Okay. And so all I'm going to ask you guys to do this lesson is to interpret, right, the slope and the y-intercept. And so you have to write sentences to interpret what they are. Okay. So let's start with the y-intercept. The y-intercept has a value of 248.6 milliliters. And so the y-intercept, right, is a point, a coordinate point, 0, comma, 248.6. And so if I'm trying to say a sentence, what does that mean? Well, this represents the x, which is tapping time. And this guy represents soda amount. And so your sentence is simply when no or zero tapping happens, we expect there to be 248.6 milliliters of soda left in can after opening. Okay. And so a y-intercept, right, from algebra 1 is a coordinate point that has a 0 value for x, and then that's the y value. And so you're just interpreting, right, in context what that means. Okay. Our next one is the slope. And our slope has a value of 2.63. Now, as a review here, slope is delta y, the change in y, over the change in x. And so this is 2.63 over 1. Okay, so this is really important. You're always going to put whatever the slope number is over 1 so that, right, you can in your brain use this to describe slope. So we say 1 for change in x, right, which is tapping time. So you say for 1 additional second of tapping, right? That's delta x. When x changes by 1. When the tapping time changes by 1 additional second, we expect, what do we expect? Well, we expect the y to change by 2.63. So just contextualize it. What's y? Y is soda amount. So we expect the amount of soda left in the can to go up, right? Increase by 2.63 milliliters. Okay. So again, this is a statistics math class, but there's no math here, right? This is writing sentences. And so really the entire lesson today is about interpretation of y-intercept, which is when x is 0, what do we expect the y to be? And slope, which goes back to algebra 1, the change in y over the change in x, and then contextualizing that, right? The change in x is always going to be 1. So you're always going to write for 1 additional x variable, right? Second of tapping. We expect what to happen to the y? Well, this is a positive number, so we expect the amount of soda to increase because it's positive by 2.63 milliliters. Okay. All right, and then the last part here of your notes, which you can print out at home, or you don't have to, you can just, write down what I write down, is this fancy word called extrapolation. Okay. Extrapolation is talking about using this regression line to predict stuff that's way too far away from the data that we collected. So let's look back at our little picture I drew at the beginning. We collected this data. I'll redraw it for you. We went out in the real world and we collected data and it looks like this. Okay, let's make up some variables here. How about the number of miles on a car? And then this is going to be price. So we went out and we collected all this data, and maybe the highest number of miles we found was 120,000. Okay, so we went and found a Toyota truck that had 120,000 miles on it, and it's going to cost this much. This is actually backwards. We would expect the price to go down, but for sake of an example, we'll use it. So what is extrapolation? Extrapolation is saying, look, you collected data around here. And yeah, I can draw this line through here like that, okay? And then extrapolation is saying, don't come out here and plug in an X value to get a Y value right there. It's too far away from the data. It doesn't make sense, right? You don't want to use this data to predict how much a vehicle is going to cost at 500,000 miles because it's so far away from the data that you collected, it might not make sense, okay? And so here, right, to tie it back to our tapping can, should we predict how much soda will be left after 60 seconds of tapping? 60 seconds, you guys. Look at the data that we collected. The data, the maximum we collected was at 12 seconds of tapping. And so you're thinking about coming way over here to 60. And that does not make sense. So you would say, right, no, 60 seconds is too far from the original data we collected. So it's just a vocab word. You just have to understand that you do not want to predict, right, things that are too far away from the data that's been collected. Okay, I'm sorry about the maintenance guys in the back with the blower. It's super annoying probably for the video, but hopefully you guys got it. That's your lesson for today. At the bottom of the homework, at the bottom of the assignment, you guys can see the homework, which should already be in Schoology for you to work on. Okay, take care, you guys. Have a good day.